Okay. Compton effect is explained by classical mechanics, quantum mechanics, hidden thermodynamics, statistical mechanics. Okay. Let's see again. Compton effect is explained by classical mechanics, quantum mechanics, hidden thermodynamics, statistical mechanics. Why not statistical mechanics? Statistical mechanics deals with large number of particles and connects microscopic behavior to macroscopic properties like temperature, pressure, and entropy. However, the Compton effect involves interaction between a single photon and an electron, which requires particle nature of light. Statistical mechanics is not the primary framework used to explain a quantum mechanics. However, statistical mechanics is a fascinating field that bridges the gap between the microscopic properties and macroscopic properties in temperature, pressure, and entropy. Thermodynamics deals with heat energy, transfer, temperature, and macroscopic system. It does not explain the interaction between individual particles like photons and electrons. Why quantum mechanics? The Compton effect, spell effect rather than effect, refers to the scattering of photon by a charged particles, usually an electron. It resulted in a fundamental shift in how we understand light. Particle nature of light, classical electromagnetism, classical mechanics predicts that the wavelength of scattered rays should be the same as the incident rays. However, after Compton observed wavelength shift, which could only be explained by treating light as a stream of particles called photons. Energy and momentum transfer. In this phenomenon, a photon collides with an electron like a billiard ball, transferring some of its energy and momentum. This interaction is governed by the principle of quantum theory. The change in wavelength is given by the Compton scattering equation, delta lambda equal to lambda dash minus lambda equal to h over m is c, 1 minus cos theta, where h is the Planck's constant, m is the rest mass of the electron, c is the speed of light, theta is scattering angle. Change in the wavelength is equal to h over m is c, 1 minus cos theta. The Compton effect involves the scattering of X-rays or photons by electrons, resulting in the change in the wavelength. This phenomenon cannot be explained by the classical physics. It is successfully explained using quantum mechanics, which treats light as the particles, photons, having the energy and momentum. Compton effect is explained by classical mechanics, quantum mechanics, heat and thermodynamics, statistical mechanics. Correct option is the option B, quantum mechanics.